Hello everyone. Chi magnetism adinga third lecture chule achaina pian na. Chi chong hintin chila hi magnetism chapter moving charges hona. Chi chapter a hu torque to moving coil ki vandalize na. Chiten hui boldi aban le chapter abana pena hu NCERT a hu magnetism and matter pa hona. Xong hui bol tha deu bar magnet hui bol tha deu hinten chu chilai lecture ai bol deu cha jo magnetism topic jo se thing se lai bona chai deu Okay, let's start. Masapena jo torque hi betang mechanics of torque formula chepita. So R tau is equals to R cross F chi chulana torque formula cho ale magnetism of torque pa hi itabang hidiam. Suppose I have a loop tai loop kanam cho. So rectangular loop na. So let's say the loop is like this. To chila hi you have one see the thing is that here this whole plane na whole loop hi it can rotate like this, okay, like this, or it can rotate like this na ki pai thai tina cho loop pa hi. So let's say some current is flowing here, current hong cho. So current cho I tiu tena la hi current I honga ta hi chi cho. Okay, so I loop in tin hilanga hi hong podo na. So let's say point A, B, C, D. Okay, it's a rectangular loop pa hi aside jong ka pip tena. Suppose let's say this chilang pa saudan pa hi B tiu tin langkha lang pa saudan pa hi A tiu tena chi him. To chilai loop pa hi he loop pa hi I'm going to place this loop inside external magnetic field. Okay, ti chu chilai hi betang permanent magnet khak koi chulai. Suppose let's say this is the north pole, hilanga hi south pole na. Chi north pole to south pole pa hi ani permanent magnet so permanent magnet chu bol ki ko hiam tele he chi hin magnetic field a hin p chu chulai na. So the magnetic field will be something like this from north to south. He chi hi magnetism na topic bana pa ko ibol deu jana chepen here. Okay, so here you have magnetism magnetic field, so due to these two permanent magnet. Okay, to north pole para south pole chenten he chi loop pa hi external magnetic field song ki koi na ale to hi value chun he chi loop a hi example on the side AB na he chi lang side AB a hin epiti dem batang magnetic force bol wa chu conductor straight conductor kha chu external magnetic field sung ki koya la chun he chi conductor pa chun current a carry ala chun force om le chuna ILB he chi pa chu chila hi AB ai hung chu ta chu. So helai AB hi straight conductor khat abana BC hi straight conductor khat, CD hi straight conductor khat, abala AD jong he na he chi pum pi hi straight conductor ai assume de ta chu. Chila ki ka gap pa hi let's say this is negligible na ale AB hi force hulang ni ha. So I into L cross B chula na formula cho L chu hulang ham direction of current chu L na chi L cross B. So you take your right hand, you curl like this, your thumb will be pointing inwards. Khutile AB hi, so force is inwards na chepen hi FAB ding kat ala hen. So FAB is inward cheta banga cho BC ya force ko izat de ha. So vileo chun current chu chilang chi chula na L is along the side, B is along the side, L cross B is 0 aji chon ya parallel ta chula na. So force is 0 on BC side. Okay, so force BC is 0. Abana chu CD khola le force holang de ha. So now current goes like this chu L hi na B chu chilang hi za L cross B. Right side in tin car le chun your finger will be pointing outwards. Okay, the force chu outwards FCD. Okay, abana chu vetang DA pa helale. So DA current is along the side, so L cross B chu chilanga chila, so they are parallel. Okay, so if they are parallel, cross product is 0 na, so therefore force is 0 on AD also. Okay, so force DA is also 0. Ale tu hin he pa he na he force a segment jo sia he na straight conductor jo sia he force he ta tu hin ga tha ji gu leng. Let's say if I view this from the top chung la para he tai kan vet su cho tai he kan vet su la sun itabang de ha. So I will have something like this. Hilanga he biom ding hilanga sium na alaya hi ki rotate thai cho. Okay, it can rotate. Ale BI hi force direction chu hilang ha. So chilang he inward chula na. So let's say if the force direction at B is like this, chipa he F AB chula na chipan he kutile C a force ko hilanga opposite chula na outwards, so that means something like this. F CD. Okay, ale force AB pa hi value is at the ILB chula na formula cho, so I into length to B is a magnetic field to B, current to I na, so that means so FAB is equals to I BB, to force is na CD yang ko I into B into B. Okay, ILB pa apply lao na. Okay, then hotele overall hello idiki pay them. So now it will tang C na torque pi lang ha. So like this na. B na torque pi lang ham. So like this. So overall it is rotating clockwise direction. Okay. Hotele net torque to no hold theta just like so R into F na. Tang hilai R happy ha. So here this is R. To A by 2. Okay. Aji chu batang chilai para chilai chan hi chi A by 2 chula na. Total length to A chula na side lang khat pa he. So again the other side also you have A by 2. Okay. So chilai jang no vale torque no hold. So here the torque will be what? So net torque will be so R into F. So A by 2 into I into B into B. Chichu hi chilang side part torque ta cho. Okay. R into B. Yeah, R into F katina. So they are perpendicular na. So plus lang af kolale A by 2 into so I into B into B. Okay, so from here if I solve I have I into AB into B. A by 2 plus A by 2 to A is na. So A to B ka koi hom na ji ko pi ham tele A into B to pi ha, small a into small b to. So small a into small b. So this is a length into breadth na. It is the area of the loop, chalai rectangular loop pa he cho. So that means I can rewrite the whole thing as so I into area into B. Okay, so here one thing, I into A pa hai na. So here I into A, so this is basically the magnetic moment. Okay, we have something called magnetic moment. Chichu piham small m. So small m is equals to I into A. Okay, so formula tabaso na bahan na bahan tayo na lahim. So I can rewrite the whole thing as, so torque is equals to M into B. Down it. Okay. I also chipen hi kimangzi be selo. So okay ha man chu piham tele in general, suppose let's try to do something here. Hichelai pa he na. Ahong ke paya la chun, let's say after some time it will be something like this. So it will have made some angle with the vertical na, with the normal with the area vector. Okay. Let's try to draw that condition. The condition pasuka jiguleo hen hitayam tazo. So let's say it has rotated. Okay. So it has rotated. NCRT follow leo hen chalai angle pi theta deute from the original area vector pasana. So now the force is C2 hilanga amchalana. So this is FCD. Langkalanga chu chi FAB. Okay. Kutele A by 2 chu ke bang na lai na chi A by 2 langkala jong hi A by 2. Okay. Torque is eating wala torque chu torque chu piham R into F perpendicular na. Ailole R cross F chala. R to chun F chu perpendicular de. Oh. Kutele I have to take component of F here. Yeah. So one component of F is like this. It is perpendicular to A by 2. Okay. Is that so here this angle will be theta. Okay. So if I try to draw like this, so this is theta. So that means this is also theta. This is theta. So therefore it's only theta. Okay. Now theta FCD jong split ball leuchun. So one component along this side, another one along this side. Hichipen hi theta. Okay. Kutele chipa hi ipidha FAB sin theta. Na langkala jong FCD sin theta. Okay. So torque is eating valachun A by 2 into FAB sin theta is yung no net torque pa so. So therefore what is the net torque? So A by 2 into FAB to piha I into B sin theta. Na plus A by 2 into FCD hu piham so I into B into sin theta. Okay. Gom khom leuchun ping pot diha zawata banga chu. So AB into so B into sin theta. Okay. Hichi in general at an angle theta. Okay. In general adding a torque formula derive good na lahim. So here how much is this? I into A into B into sin theta. azawa chu I into A chu magnetic moment tiu chu na. So this is mb into sin theta. Okay, so this is the net torque. Ale to chepa hi vector akasit he chu. If I have A cross B chu pi ha AB sin theta chu la na. So that means AB sin theta I can write as A cross B. Chita banga chu mb sin theta pa hi. So I can write torque is equals to m cross B. Okay, so chepa hi actual formula of torque. Na by ha dio pa chu. Okay, m cross B, where m is the magnetic moment, B is the magnetic field. Okay, hilai hi betang chi vela chun hi loop khat bo se chula na. So sometimes you have many windings. Okay, number of loops to n ka thile hen na. Let's say so for n loops. Okay, so magnetic moment chu pi de ha. So what is the magnetic moment? Aji chu chi numerical question ke tong ji na. So m will be so n times I into A. Okay, so this will be the formula. In general, magnetic moment formula pa chu na. So n into I into A, where capital N is the number of loops. Okay, then torque formula chu pm m cross B na. So here dekha ga value hen, so you can note here. Mechanics are torque chu pm so R cross F. Na electrostatic are torque chu pm so P cross E. P chu dipole moment hi na, E chu electric field. Khotela magnetism are torque chu pm so M cross B. Atoma hi poi mo cho. So all of them are important. Okay, question kan ga solve the na. Conceptual question kan. Velocity uniform magnetic field KP na, magnetic field KP along the positive y direction. So let's try to draw it. So x is a, so y is a, so z. Rectangular loop of sides 20 and 10 centimeter with current 5A is in the YZ plane. So YZ plane too. So I'll try to draw like this. Okay. So side has 20 centimeter, has 10 centimeter. So current current to 5 ampere is a the current is in anti-clockwise with reference to the negative x-axis. Negative lang apa na si this is pa positive x cho na. So negative chu lang hi cho. So hilang apa he tai nan valve loop so nan valve you will see it as anti-clockwise. So that means current is actually going like this. Okay. So let's try to draw that one. Chisat ham chi 5 ampere. Okay, current cho na. So magnitude and direction of torque. Okay. Khotele magnetic field cho itium ham magnetic field cho it acts along positive y direction. Khotele so it is something like this. So B is acting like this. Okay, so this is B. Yeah. So tuzun azwai ji ta bangzon ga thaji ko leuhan. So loop cho time cho. Okay, let's rectangular loop. So chung lang hu 10 centimeter. Lang khalang chu 20 centimeter. Okay, magnetic field cho tium am. Magnetic field cho time cho. Okay, so something like this. So this is B. Ale to chu a side hoye zo ta bangson ABC bol ki lechon A B C D na. So A B a to force hoy lang ni ha. So here current to current ga ji tha lechon na. So current is what? So A to B, B to C, C to D and D to A. Okay. Kutele A B a hi DL chu chalanga chi na. So B jong chalang chi they are parallel, so force is 0. Okay, force is 0 on AB. Kutele C D a jong force 0 na. Ale BC a khudale so DL jo chalanchi ya magnetic field jo chalanchi ya so DL cross B. So right hand in car lechon your thumb will be pointing outwards. Okay, so here the force is outwards. Abana jo DE a helale so DE jo DL jo chalanchi ya magnetic field chalanchi na so L cross B right hand in car lechon your fingers will be pointing inwards. Okay, so cross kasi is like force by. Na ale force pa value jo that ham I into L into B na current to 5 into L jo that ham length to 10 centimeter na so 10 into 10 power minus 2 into b to zat ham 2 into 10 power minus 3 chi hi zat ha. So 5 2 are 10, 100 into 10 power minus 5. Okay, so I can write this as 10 power minus 3. Okay, confusion lo na na. Okay, khutile to hi talk ati chula na. So now you just see if tang hilanga hi nan sot do wa hilana sot su wala chun. So the rotation will be something like this. Okay, so let's see. Hilapan ga view le chun, hilapan ga view le chun. So if you view it like this, so something like this. Chi A hiza, chi B hiza. Now the whole thing will try to rotate about this. Okay. Kutile BCR force who, let's say it is chirang tiu na chi. So chi 10 power minus 3 na. Kutile ADR force who langka langa hi ngai na chilanga hi. So 10 power minus 3. Kutile torque pa heavy leuchun. Abale hichipa heavy ha. So it is something like this. Okay, axis na. So it is going to rotate like this. Okay. Kutile chipa hechi zat ha chi. Chi 20 by 2 to 10 na. So that means this is 10 centimeters. So 10 into 10 power minus 2. Okay. Similarly, zong here 10 into 10 power minus 2. Okay. Also a torque is so R into F2 torque ta na. So what is the net torque here? So therefore net torque equals to so R into F. So 10 power minus 1. Okay. 10 into 10 power minus 2 to 10 power minus 1 na into force who 10 power minus 3. Okay, plus ibola plus ham tele so to khatpa hilanga chi khatpa join langa chi ani nu na clockwise sense ki bang na rotation, sense of rotation. So direction of torque ki bang tine cho. Okay, you have to add them. So khatpa jong who 10 power minus 1 into 10 power minus 3. So that means if you solve this you'll have 10 power minus 4 plus 10 power minus 4 which is 2 into 10 power minus 14 nature. Okay, Newton meter. Kutele option jo sia khu ki bangso ke chula na chi head heading what so value pa jang ka hold do jana hela hi value hold do lawa direction akona jo khu option na tik theu cho chila hi ale to chu hitia ke pa la chun. Okay, so that means it is rotating like this na. Kutile torque direction jo hilang ni ha. So ake pa ina la hen na, you take your right hand and you curve it along this side. Hitin curve la chun, so your thumb will be pointing along that side. Okay, chu ho hoi lang ha. So chala A B C Z pa hoi ka tha ji leu chun, so A chu chala hi za. So B C D. Okay. Aban axis of rotation chu tai ham chala na. So something like this. Okay. And BCR force ko vela chun chi outward chala na. So which means BCR force who it is along this side. ADR hi along this side. Okay. Kutile hitai ke peita jata hai. Okay. Right hand in Paleochun, your thumb will be pointing towards this side. Okay, this is the direction of torque. This is negative z axis lang ajola na. Okay. So answer is negative z direction. This question pa hai na exam ba honga le to hi che pa hai na numerical part hi calculate ngai lo na jahing direction pa bo se hi. So hi tang ke paiding so torque will be along this side. So in here wala hi jing option atik theo. Okay, you have 100 turns close wound circular coil. Azo ka seban coil kiti chu windings tabanga turns tam ta hungam thai chura na. Suppose you have 100 turns here, radius jong ke pi na chai current jong ke pi. What is the magnetic moment? Magnetic moment so pi ha N into I into E na. So number of turns of 100, current is ha so 3.2, so 3 by 2 32 by 10 na. So into area to circular coil has a pi r square. Okay, so pi r square is so 3 point pi ga ko pi into r so ha so 10 centimeter 10 into 10 power minus 2 the whole square. Okay, so solve that one. Okay, so you have 32 pi into so 10 into 10 square 100 into 10 power minus 4. Okay, so 32 pi into 10 power minus 1. So 3.2 pi ti nature. Okay. Detail solution hen wala pi value put bilang multiply bol le na. So important is the formula. Sipain hedio. Okay, bana 2 ampere current is flowing through two different small circular coils having radii of radius ratio kipi na lahi r1 by r2 chu 1 by 2 kipi jo. Question na so the ratio of the respective magnetic moment is m1 by m2 ihol na chu peham. So n1 into I1 into A1 divided by N2 into I2 into A2. Okay. So like PKPM, a current 2 ampere is flowing through two different. A current same current. But the number of turns it means that there are so two small circular coils. Coil number of coil here one so in the winding here so there is n is 1 for both, so that means area 1 by area 2. So pi into r1 square by pi into r2 square, so pi gets cancelled out. So r1 by r2 the whole square. Okay, r1 by r2 so 1 by 2, so 1 by 2 the whole square is 1 by 4, so 1 is to 4. Okay, bana solenoid na, so small part. Solenoid on here p heading ham must have magnetic field direction pi bata. If you have a solenoid and the current is like this, so current is like this. Okay, let me use different colors. Okay, na current tayo chicho. Chilang podo na. Kutele current jidan tudungzui hin na solenoid ahin right hand pa ko curl leochun, so your thumb will be pointing towards the direction of magnetic field. Okay, right hand thumb rule pa na. So coil circular coil magnetic field direction boldan here chola na. So you curl along the direction of current, fingers points towards field. Heche pa ne apply theo cho chala jong here. So current hita chila chun magnetic field pa che hi na direction cho. Hechi magnetic field lines dan cho solenoid na. Magnetic field value here due to formula by hat jing de chala dang ha sim lo. So magnetic field inside asungana is solenoid. Lang pia chi long ki mang ji long solenoid. Chuchu pi so B is equals to mu naught into N into I. Okay, formula chu chi jing na chi ben here. Chila N hi piam. So what is N? N is the number of turns per unit length. Okay, so number of turns divided by length of solenoid. Okay, total length to L here lechun. Right? So number of turns to N here lechun. So small n to N by L. Okay, number of turns divided by length of solenoid. Okay, so that much. A long solenoid of radius kp in din has 100 turns per mm. Okay, now tita bang question ai do nom ke jana helai velo chun chi millimeter kiti cho millimeter to SI unit lo cho we have to convert this into meter. Hita number of turns per millimeter per centimeter kiti phale you have to convert this into turns per meter na. So 1 mm2 is that meter ha. So 10 power minus 3 meter na. Okay, this is the conversion. Kutile 100 turns. So divided by per kiti to divide na. So 10 power minus 3 meter. So this will be 10 power 5 turns per meter. So minus 3 chung hong lasan plus 3 ta chu. Okay, so 1000 into 100 to 10 power 5 is jing na lai. So current kpm current so 1 ampere. So magnetic field strength at the center so sungana. So B to that dingham. So mu naught into N into I. So chalai sipa is small n so capital N hilaw na. So mu naught to that ham 4 pi into 10 power minus 7. Abana N to pm 10 power 5. Current to that ham 1 na. Is that ham chi? So 4 into pi to 3.14 into 10 power minus 2. So which is for 4 are 16, for 1 is 4, 5, for 3 are 12. 10 power minus 2, Tesla. Okay, option C. Okay, next, a long solenoid is formed by winding 70 turns per centimeter. Okay, to small entropy kpm 70 turns per centimeter. Na khotila centimeter pa khu meter convert dio. So 1 centimeter equals to 10 power minus 2 meter. Na conversion so 70 turns per 10 power minus 2 meter. Okay, that has 10 power minus 2 chung ang 7,000 na. So turns per meter. Okay. Small enum ta. So now you have to find out field produced inside. So therefore B2 pm mu naught into n into I na formula so 4 pi into 10 power minus 7 into so 7,000 into I choose 2. Okay. So for 2 or 8, 8, 7 or 56. 56 into 7, 8, I can write this 22 by 7 na. No, but 3.14 on zitaw. Aji 7 to 56 ki cut hai ja na. Pi into 7 into 2 into 10 power zata minus 4 na. Okay, so 7 ang cut na lai. Okay, khutile zat deta lai. So 56 into 22 into 2 to 2 are 4. So 56 into 40 nay. 4 6 are 24, 4 5 are 20. So 2 2 4. So 2 4 6 4. Okay, it's like 7 to 2 can multiply so this 2 should not be here. Okay. So 10 power minus 4 na lahin. So 7, 8 are 56. Okay. 8 2 are 16, 8 2 are 16, 17 into 10 power minus 4. So this is your answer. Okay. Option B. Okay, next topic to moving coil galvanometer na. Chipen hi detail na functioning construction hoi patia NCRT na video chilai hi detail ka chilo do. Okay. So I'm just going to derive one or two relation here na sensitivity ho numerical ake manje ajo chila ka explaining in then ebanga proper functioning ho na construction ho yebo na NCRT textbook so diagram jong NCRT kan manina lai hem so adang cho en hon NCRT ki sim thodeo so galvanometer kiti chuchita bang hai na so something like this. Okay, so here you have to wire ke connect na so one will be red, another one will be black na ta hai khudele hechi hi ammeter pa hai na reading ki bol pa chi hi jana chala scale ke ti pa hai. So here tipai pointer pa hi it can deflect. Okay, it can deflect right left and na. So usually this pointer will be exactly in the middle. Okay, galvanometer achu chala 0 ma hilanga hi 1 ampere, 2 ampere, 3 ampere na 1 ampere, 2 ampere, 3 ampere. Ampere generally na so galvanometer to so it can measure only small current. Okay, ji chu alang pya chi milliamperes hovela na he hongum ji beta a reading pa he na. Okay, khutile chi scale part chu chi za asung langa he na asung langa hi tabangum ham tele chi be he whole thing. So this whole thing. Okay. To chu chala hi permanent magnesium chuna lai permanent magnet chu bol ki koi ham tele magnetic field external magnetic field ki supply na dinga chi koi na lai hem ale che sunga hi so you have a soft iron core, a core ki ti chu asunung pen na core ki ti khat omten he chi core chunga he ptm tele winding jata hai khaw ki vel na ta hai. So you have many windings here. Okay, he chi winding ki bol den chi winding chunga he chala current chi chu. Okay, current chi na khutile he chi winding ho he na so chi winding ho he chala pan vele chun azo langa torque derivation a rectangular loop iman pau chuna hila hi you may get a circular loop like this. Okay, current is flowing na khutile torque ho hongum ding rotation ho hom ta chula. Okay, so let's say now to chala permanent magnet dom jana lang pia chu he chu so when you have something like this current lose in na so current supply ho chu chala hi so let's say here chala binding winding wise current supply chi tu na la he khutile current supply hong chi le chun if it is placed inside external magnetic field so torque is going to start acting. Okay, so let's say torque hila hi chilangai force kharam tiute nakhala force is chilangai tiute azolanga torque derivation ni bolta bangma chana khutile chilai pirta. So now the whole thing is will try to rotate clockwise. Okay, clockwise ki rotate go ding tu hin thla leu chun itai clockwise ki rotate chu ai wanga chu itai aki rotate pe pe chun chilai pointer pa hitai chi ding hirang pa chi chula na, but we want this pointer to go only up to certain limit. Okay, china ding a chu chilai spring khar ki koi chu chilai spring pa hi hitila na rotate phala spring pa chu ga che che na ga che che ding azo zo na le tai hechi khala hi na hechi hela hi achi sa lo ta chu spring pa ga wal tan tin le na. So now if you release spring pa hi hung chi ke de na spring pa hin pointer pa an nung kai ki de ta he. Okay, na laya hi alai tai vela chun spring khatam meta chi spiral ta ba spring khatam meta he just spring hin pi bol ham tele to chu suppose now force acts like this. Okay, khutile cheteni force ja he torque hum da chula na torque ja chu it will try to rotate anti-clockwise aita aki rotate ala chun he just spring pa jong hi tai he chilang hi chi chula na. So spring pa chu chilang na kai favor na short favor chun so it will go up to certain limit. Okay, ai wanga chu chom kha chu phala spring pa hung ham ki de ta chu. Okay, chi phala chun it cannot go beyond this na he chi khela chi te loading na thawa current na la do phala chun chi force ni ahung manala na so chi spring pa an le kai ki de chu an le kai ke ding tin so the pointer will come back here. Okay, simple ta setting chu chu na magnetic field ho jong he vele chun chila he radial om chu if is radial om ham you read your NCERT. Okay, na chilaya soft iron core ho jong hi bol iron core ke mang ham ti ho vel na he cho cho bona na sim diu to a function pa bo se jon he diu can explain dana la him he che pa he so it can rotate clockwise anti-clockwise or clockwise. Okay, ai wanga chu ki rotate pe pe thelo na je chu spring pa hin a prevent cha. Okay, okay then khutile let's take a condition at equilibrium. Equilibrium chu piti na ha suppose to hi current hung chi chala na current hung chi ya chu so let's say the pointer starts going left side. Okay, anti-clockwise khutila spring pa he ki son phai chala na ki su ga che che ding chom kha jo phal ki ngare ta chu spring pa he chom see up to certain limit you can push. Okay, beyond this you cannot push anymore na. So now you will get an equilibrium. He chalanga spring force pa to spring force pa chun udang spring force ki chu restoring force la na. So torque chun hilanga kaya la chun spring pa chun lang khalanga asot de. Okay, right, so the spring force will be towards the right side hilanga he torque pa na so force due to the current. Okay, okay he spring force is restoring torque tiu na spring achu restoring torque chun so chila actual torque pa hai na torque due to circular coil pa ong ki balance ala chun chu equilibrium hi jana. Let's say so here restoring torque so this is due to spring na so this is equals to so torque sing to khat pen he current ja torque pa jana. So now this is equals to it's restoring torque pa hai na so k into phi tak k represent so like k hi spring constant in is phi to amount of deflection na is that ki deflect do in terms of angle khutile chalai torque pa he pe ha so n into azo formula pen so n into I into A into B chi lo na so for n number of turns acho n into I into A into B to jo chalai hi. So if I write k on the right side I have n into I into A B divided by k. It's a amount of deflection. Okay, okay khutile chalai he diu chuna batang hilaya relation mo chu phi is equals to so n a b n I a b so divided by k am da chuna k to spring constant is n to number of turns I to current a to area of coil B to magnetic field chala na. So now tun current pa hi velanga in coil chun piung pot ha so phi by I so this is n into A into B divided by k. Okay, to chalai relation kanang pot ta chu he chalaya phi by I ki te pa hai na so this is what we call current sensitivity. Okay, chu formula khan he do na abala to hi I hi betang ohms law of V by R chula na. So from here if I put I is equals to V by R, kutile 5 hu pi ha 5 hu N into A into B, so into V by R. Okay, V pa ho velan ko leo chun, so 5 by V chu pi ha 5 by V chu N A B, so divided by K into R. Okay, so you have another relation here. Hilaya 5 by V kiti pa hai na, so chipen hi voltage sensitivity. Okay, chiten hi point he do na galvanometer numerical ki dong de chu chila hi. Okay, so current sensitivity to voltage sensitivity na chiten ni chu. Okay, let's see. Hi chipen hi question hi NCERT exercise akona kila so chipen hi na. So here you are given that a moving coil galvanometer, two moving coils M1 and M2 have the following particulars. So assuming the torsional constant of the springs are same, so spring constant kibang na K value kibang, what will be the ratio of voltage sensitivity? Voltage sensitivity so 5 by V of 1 divided by 5 by V of 2. Ama ratio whole vinti chula na lai. So N into A1 into so B1 divided by K into R1. NAB by K into R na voltage sensitivity cho. So banas khatsu N2 into A2 into B2 divided by so K into R2. K bang so spring constant ke bang na. So K gets cancelled out. Dang hi value na put it so. So here I have N1 by N2. Okay. A1 by A2. So B1 by B2. Abanahu R2 by R1. So denominator should come so na. So R1 who comes ding R2 pi chito de. So you put the values. N1 who zat ham 15 by N2 to 21. So A1 who zat ham A1 to pi R value kipi na la. So 36 into 10 power minus 4. Okay, 3.6 to 36 takazi so la. So 1.8 to 18 into 10 power minus 4. So into B1 so piham 0.25 to 25 into 10 power minus 2. So 0.5 to 50 into 10 power minus 2. Okay, R2 to piham 7, R1 to 5. Okay, got solved for that. So minus 2 minus 2 minus 4 minus 4. So 25 into 2 is 50, 18 into 2 is 36, 2 gets cancelled out. So 5 3 are 15, 7 3 are 15. So 3 gets cancelled out. Not 3 1 is 3, 3 1 is 3. Kutile finally zanong you'll have 1 by 1. 1 is to 1 din so ratio. Okay, so option 1. So chipen hina kasi so NCERT exercise ako kila hai jana chi. So tempat practice na ding achu kan ko hi ja. So same question ahi current sensitivity jono hol de so try bol da. Okay, now we jump into bar magnets. So magnetism and meter pa ko na moving charges penki chai ta to hai. Okay, so now we go into bar magnets. Okay, bar magnet here so ke na. So if a bar magnet is freely suspended, then the point na I know that the ends which points towards the geographic north. So R ta north pole lang ko lang side pen na so north pole hong di ya. Bana so the end with which point towards the geography south is south pole. Okay, GEE basic class high school azon sim sao na. North pole khato ki repel de. Na south pole khato ki repel ding. But a north pole will attract a south pole. Okay, so basic stuff. So we cannot isolate a north pole and south pole. But electric dipole ko iti ki mo. So if you have a negative charge, so kept at some separation from a positive charge. Okay. So electric dipole ahi, I can remove this separately. Lado minus charge within chipen na. Lado I can have a single minus charge. Okay. Na chang si am thai chula. I wang so bar magnet ahi PTM tela if you cut this into two. Okay. Two hin chi bar magnet pa hi chalang cut leo chun. Hi chalang side pa hi you will get another bar magnet, smaller bar magnet chalang north pole hilang south pole. Okay. To so lang khalang azong hi ta hi bar magnet khan hom ding din. So this will be south, this will be north. okay na point chu he chi south pole bo se chang si thailo ti ne chu okay so monopole is not possible so magnetic monopole does not exist okay south pole bo se chang thailo north pole bo se chang thailo na phal chu north pole to south pole chu khom jing ti ne chu okay that is the point para chu cutting a bar magnet into two result in two new smaller bar magnet okay chipen hina chalaga jipen he the basic bar magnet na point is na abana magnetic field chu vetang so not apara south chula na okay so what is the answer here so magnetic monopole do not exist so this is correct okay ibolam thelo ham tele azo phal magnetic field line involved na because magnetic field lines are continuous okay so they form closed loops actually both are correct and R is the correct explanation okay na chu heta facts the bang chu chipen he to magnet bar magnet huma la chun next aso p hold ham he chi NCERT ya phatia ke mention lo na he jong la chala he question ho ki do ja chu bol oh pole strength ki ti hi pi dina so what is pole strength pole strength of PM it can be defined as the strength okay the strength of a magnetic pole to attract a magnetic material na thi man hu haruma halom chula na thi man har ki ti chu PM de la pole strength hi hard in nature okay so it has higher pole strength so the strength to attract another magnet is very high na so pole strength is so in general I hon batang as a electric dipole acho plus q minus q ti chula na chi magnitude of charge so to banga cho chila hi plus m minus m ki ti cho hi m pa hi pm pole strength so north pole is given plus m south pole is given minus m okay that is the pole strength so the magnetic dipole moment to hi azo la so bol so n into I into h a magnetic moment is ana so you have something else for a bar magnet that is a magnetic dipole moment so pm so pole strength into distance of the length of the bar magnet okay okay ba na betang if I have a electric dipole so separated by distance L kutele dipole moment so p chu q into L chula na so charge into separation chula na chala hi chito banga so magnetic field along hi so m into so separation m into L chu magnetic dipole moment ki cho okay okay now next stuff chala hi so bar magnet chung changa na suppose I cut a bar magnet like this ipi so de me ta chala na bar magnet ni ki home can ki cho so what happens to the pole strength pa chu iti them all sum them hard mo sum them I lole ipiti them so here if you cut a bar magnet like this okay so the pole strength remains the same plus m minus m okay ai wanga ki khel chu pi ham magnetic dipole moment ki khel ta chu aji chu length ki khel ta chu na ji so now atila chu initial chu let's say length pa chu 2l ti utena japan here so if the length is 2l so now if I cut into half so one half will be l okay so L chu pm 2l by 2 na so here jeptang new magnetic moment dipole moment chu pm so m into so 2l by 2 now it becomes half so the magnetic moment dipole moment also reduces by half okay na chu chung den hitila ne cut vale magnetic dipole moment chu becomes half okay abana chu hitila ne cut vale pitira so if you cut it along the length so first thing you will observe is that the pole strength now reduced to half m by 2 ki surta as a pole strength okay abana magnetic moment chu pidham dipole moment chu now pole strength is m by 2 eva length hi ki hilo pichura na 2l ma chula length chu so length chu chum lo so the length is still 2l so but m becomes m by 2 so magnetic moment formula apply legend pole strength into length chu you have m by 2 so here also it reduces to half okay magnetic dipole moment na okay thumna chu chipa he so he chip magnetic bar magnet paso na he cone wala if you bend it okay so bend it in the form of a semicircle example khutile ichana ki khel de ha to chu na bend wala let's say chipa half circle ti na magnet pa he so chilai para chilai distance is ha so he pi into r chula na ji semicircle so and pi into r pen hipiam so this is basically 2l okay so bar magnet chu semicircle na he koi wale so 2l is basically pi into r na so equal bolo chun pi ha so 2l is equals to pi into r. So r so pm 2l by pi. Okay. Equation 1 ji lewa na chilai him. To chu tang ILB formula na force magnetic force on a conductor formula I into L cross B na L chu pita L chu net displacement diu na. So if you recall it, L was net displacement. Chita banga chu chilai jong hi. So I have one n here. If I want to find out the magnetic dipole moment, so magnetic dipole moment so pole strength into length kiti chula na. To length by displacement, shortest distance by la chulai. So chisa dingam this is 2 into r. Na semicircle chula na. So that means it's diameter teenager. Okay, so that means 2 times radius. So which is what we write here. So magnetic dipole moment will be, so pole strength so if you bend, pole strength remains the same. Okay. Kutela pole strength into 2r pen pm. So this one diameter pa hai. Okay, so this is 2r. Now length of magnet pachu. So there is the displacement. Okay. So let's try to make a result na chalai formula ko na hi. So magnetic dipole moment is basically pole strength, okay, into so net length alole displacement between two poles alole ends. Okay, net displacement between the two poles na. So pole strength into net displacement between the two poles to magnetic dipole moment. So hitin by hat a formula pa hai na. Khutila chu line apply vala chun. So here the magnetic dipole moment will be m into so 2r he pm. So chipole to chipole ke ka shortest distance pa na displacement jo chu hungi cha. So that is 2r. So r to pm 2l by pi. You put it here. So you'll have 2m by pi. Okay, chu new dipole moment na. So if you have two bar magnet placed like this at some angle pa theta tiu da. Kutile net dipole moment resulting to pidham so vector addition. So this one. Okay, direct apply using na. Okay. So like point mo south pole, north pole. Okay. And direction pa he magnetic moment he magnetic dipole moment he na. Batang charge dipole moment direction to have from negative to positive chila na. Chita banga cho chilai jong hi. So it is from south to north. Okay, m magnetic dipole moment direction pa hai na. It is from south pole to north pole. So that means here you have m1. Okay, so here you have m2. Ani niyo na ho outwards ako honjo. Okay, so like this, two vectors like this. So angle theta. So resultant will be a square plus b square plus 2ab cos theta. The formula pa ko na. Okay, then let's try to solve some questions. So an iron bar of length L has magnetic moment M. It is bent at the middle such that the two arms makes an angle 60 degree with each other. Hita hi bar magnetic. Okay, so north and south. So length to L na. Kutile alaita hina bend you. So you have to bend it like this. So it is bent such that it makes an angle 60 degree. Okay. Kutile a length hi khat hi L by 2, khat hi L by 2 ta so. Okay. So north pole, south pole. So to hi question chun pido ham so magnetic moment of chipene to chola na chi. So now I can rewrite this as chipai betang. I can think of this as two bar magnet like this. Hilanga hi south, north. Hilanga hi north, south. Okay. Angle jo kpm angle jo 60 degree. Okay. So that means magnetic dipole moment direction evaluation south to north chilang khat chi na chepa hi m1 diute. Kutir khat pai tia lang zo hong chola na. So formula apply thani so ani yuna hilanga chi ngai cho tai. Okay. So therefore to chepa hi produce diu na. So chepa hi produce diu within so something like this. We have to produce on this side. So this is m2. Okay. And this is m1. Okay. Kutile so chi m1 hong iding hi m2. Okay. angle z ham angle chu 120 degree. Okay, not 60. Okay ba? Achi chu chilai para chilang ta he vector ni ta chila chun angle chu chilai theta he la chun vector product ki apply ji chula na chalai chu. So therefore we have to produce it like this. Okay. So m1 khuza ding ham. So m1 will be so pole strength chu m into length chu ta he l by 2 ta chula na. Ati la chu m hi za minus m. So length l he la chun magnetic moment initial achu ta. Question chun magnetic moment is capital M ati chula na. Capital M chu zan ham. So m into L. Okay. Khutela m1 hi ham m into L by 2. So which is basically capital M by 2. Okay. Abana m2 hu ham. So m into again L by 2. Chichu capital M by 2. 2 in vector addition formulas apply legend. So therefore, so net m. So this is m1 square. Chichu m by 2 square plus m2 square, m by 2 the whole square plus 2 into m1 into m2 into cos zeta 120. Okay, so under root. That's a soft lesson. So 2 gets cancelled out. Cos 120 who minus 1 by 2. So you have m square by 4 plus m square by 4 minus m square by 4. Okay, under root. So m square by 4 cancel out. Root over m square by 4, so m by 2 tinacho. Okay, so this is the answer. M by 2 na. Okay, next. A magnetic moment of an iron bar m. So iron bar ka kitna ta hai. So north pole, south pole tiyo na siya. Length to L tiyo te. Kutile plus m to minus m. So initially it is given that magnetic moment is capital M. Capital M so small m into L. Now equation 1. So it is now bent in such a way that it forms an arc of circle angle 60 at the center. So he chipa in a bend na, so like this. Itaiki bend da so. Semicircle wang hilaw so Japan itaiki bend in. It is given that this subtend angle 60 degree at the center. Okay. Khutile hichi radius by r tu na Japan here. So now we need to find out r, okay? Betang r ka na met sa r ka tai r ka huma. So radius r, suppose let's say length of arc pa ko. Si r here, si theta here, hichi l here a relationship ita. So here l is theta into r. So you have one relation like this. Okay. This is when apply legend. Chila L ni kipi juna. So here, how much is this? Is that the But if I have a full circle, so this is 2 pi r, okay? By 2 pi r na. So 2 pi r chu hilaila chu. So I have to take only this part. So that is 60 divided by 360 into 2 pi r. So that will be the length of the arc. Okay. See. So length of arcs will be. So let's say this is x tilde na Japan. X tilde. Okay. To hi x hi hold na. X pa hi pm. X is basically L. Okay. Okay. Mislead lo na ting L ma malaw na lahi. So sila L hi pm. So this is basically 60 who pi by 3. Okay. So pi by 3 by 2 pi into 2 pi r. Okay. Here chalai para chalai ka hi 60 degrees is overall to 360 na. So abana length to 2 pi r is. I want to find out so in terms of L. Okay. Solve legend. So you have so pi into 2 pi r, so divided by 3, 2 are 6 pi. Okay, pi gets cancelled out. So 2, 1 is 2, 2, 3 are 6. So pi r by 3. Now, therefore, L r so radius to 3L by pi. Okay, equation number 2. So now I found out the radius. Okay, radius net wala chun a formula chupita kasi bang so. So here hichi net pa hai na. so genet pa he so pole strength into so displacement net displacement pa he na so they will give you the magnetic moment okay dipole moment so now our job is to find out this length displacement pa he na pole strength ki khelo chala so again you will have here plus m minus m okay only displacement you have to find out the displacement can find out the so now what I can do one thing like this so triangle niya kop can so this is 30 again this is 30 yeah so chilai pa chu x tileuhan lai pa lai chu x tileuhan so displacement is 2 times of x plus x to net displacement ta lai okay the whole idea we chi r is a chi x is a 30 I can use trigo here so chu sin 30 chu pm so x divided by r okay or x to pm r into sin 30 to 1 by 2 r ko pm so 3l by 2 pi okay x to na what the displacement to pm x plus x so x plus x will be so 3l by 2 pi okay so plus 3l by 2 pi na chu 3l by pi okay equation number 3 na finally so therefore magnetic dipole moment of pole strength into so 3l by pi yeah so m into l ko capital M chala so therefore this is 3m by pi okay so answer tempa length di na hejong le ni question chala ji okay so you have to learn how to do it okay potential energy and I think after this you have field lines and okay betang chilong hi derivation maka boloding formula chuveta so electrostatic na potential energy a formula chupita so U is equals to minus P dot E chichula na formula cho chito banga so magnetism acho magnetic potential energy H piung dia so here this is minus M dot B okay torque hung ne chon P cross E okay torque to M cross B na energy so minus P dot E minus M dot B so which is minus MB cos theta okay this is potential energy na magnetic potential energy okay so let's just solve question na so a magnetic dipole experiences a torque ke picho chu M cross B na MB sin theta dine cho MB sin theta chu za kpm chu 80 root 3 kp cho lai so ga solve lesson pm so when placed in uniform magnetic field in such a way that dipole makes an angle of 60 with magnetic field so dipole chu chilanga si na M chilanga sin din so magnetic field chu chilanga si so angle between them is 60 okay Hotel M cross B MB sin theta by angle between M and B chalana. Hotel that is 60. Okay. So how much is this? So MB into sin 60 nature. Sin 60 is 80 root 3. So MB into so sin 60 to root 3 by 2 na. So root 3 by 2 is equals to so 80 root 3. So root 3 gets cancelled out. So MB value is 160. Equation 1. Na. Question should be potential energy though. So what is U? So minus MB cos theta, cos 60. Okay, minus M dot B. Now dot to cos is one angle between MB to 60 is I can put it directly. Okay, so minus MB to PM 160. Cos 60 is 1 by 2. So this is minus 80 joules. Okay, so answer is minus 180. Okay, so magnetic potential energy when magnetic bar magnet M is placed perpendicular to magnetic field B. So it's a bar magnet. Okay, so let's say so north pole, south pole na magnetic field to hilanga chi na B. Okay, perpendicular ke jo 90 tine chulai. Okay, khutile energy ki dong chula na khutile M chu hilang ha. So where is magnetic moment? Magnetic moment is from south to north like this. So this is M. Okay. Energy to PM, so minus M dot B, so which is minus MB cos 90. So cos 90 is 0. Okay, so therefore energy is 0. Okay, hotele to hi. I think we have one more. Hijong hina NCRT am lo cho so outside akidong tabang na. he vibration of magnetic needle na topic chumbale DC Pandey ameta head nomwala. So you can refer this to DC Pandey. Okay. Book chum zani la ho. I think you have one book, Objective Physics, okay, by DC Pandey. Chala ho meta. It's a vibration of a magnetic needle inside external magnetic field. Heading so. Ale hitai vibration hum phala time period bone head so je. Here's a time period formula so piham. So time period is equals to 2 pi into so root over I moment of inertia divided by so magnetic moment into magnetic field. So this is your formula. Okay, so let's apply this. Question in uniform magnetic field B ki P na so B chu piham so 0.49 is 49 into 10 power minus 3 din so. Okay. Abana who performs 20 complete oscillations in 5 seconds. 20 oscillations in 5 seconds. Per second oscillations of frequency ki di na ji. So hotele hele frequency he piham so 20 divided by 5. So 20 oscillations in 5 seconds means 4 oscillation in 1 second. Okay, that means 4 per second. It's a frequency di nature. Okay, so number of oscillations per unit time. Okay, so per unit time that is called frequency. Okay, the frequency home as a time period should be reciprocal of frequency na so 1 by 4. Okay, this is your time period. So time period ta b ta odang p kipia. So the moment of inertia lang kipina. I chu pia ja kipiam. So moment of inertia chu so 9.8 into 10 power minus 6. Okay, chizong chu kipi. So if the magnitude of magnetic moment is x into 10 power minus 5, then x is m whole na. So everything is given, put it. So time period to 1 by 4. So 1 by 2 pi into 2 pi. So 2 pi into root over so 98 into 10 power minus 7. So divided by m who ki hello whole dot do b to 49 into 10 power minus 3. Okay, solve down. So 49 into 2. Okay, to 98. So 10 power minus 4. Okay, so 2 pi 1 by 4 2 or 8 pi is equals to root over. So 2 into 10 power minus 4. So divided by m. Okay, square both side. So 1 by 88 or 64 into pi square should be equals to 2 into 10 power minus 4 divided by m. Okay, so cross multiply m vailang ahong sa walang 64 pi square zilang asol leuchun. So 64 into 2 so 128 na 128 pi square into 10 power minus 4. Okay, so I can rewrite this as 1280 pi square into 10 power minus 5. Hita ibal ka bolham tele hila 10 power minus 5 amsa. Okay, that is very tricky na. So therefore 1280 pi square. That is your answer. Sibang so chalai vibration as a formula to both a na ji head wala solve thai okay. Magnetic field lines pen hi to electrostatic field lines I ball pen ko na he chi point gu mo sim vilang ki bang chat cho ki bang lo chu piham there is only 1 point difference. So electric field lines it goes from positive charge to negative charge na. It does not exist in a loop. Okay, loop it electric field ako na. But in magnetic field it always exists in a closed loop. Okay, na magnetic field lines ki is closed loop jing dito. Okay, that is the difference. Adang si ki bang so okay na. So tangent at any point gives direction of magnetic field at that point. Okay, so two lines cannot intersect. As it's okay intersect there will be two different points at one two different direction at one point na at the point of intersection. It's all bang. So magnitude of field lines is proportional to number of magnetic field lines. Okay, so all these are same. Okay, here too magnetic field lines always exist in a closed loop. Okay, NCRT libo ki pizza just like likan zi na. So electrostatic collector never follow point group pizza na. It's a point group bond and symptom. Okay, that is magnetic field lines. Okay, magnetism I think our last topic na. Japan here magnetization and magnetic intensity. Butang magnetization to see suppose tu chana magnetic moment in simo chalana. So magnetic moment direction to pm south upper north chana. If you have two or more magnetic moment, aki to vector addition a follow chalana. They add up using vector addition. Kutile see all this magnetic moment net magnetic moment paso na vector addition applies on net magnetic moment paso if you divide it by volume. Okay, so that net magnetic moment per unit volume, so that is what we call magnetization. Okay, now what is magnetization? It is the net magnetic moment per unit volume. Okay, so magnetization so numerical gaji capital M ki represent his Japan magnetization here. So capital M is equals to so M net divided by volume. Okay, so definition so application so piham see suppose I have a solenoid na NCRT ta bangsa can explain. So NCRT kalwala can explain loading. So whatever is written in NCRT I'll explain here. Suppose I have a solenoid. So solenoid I current hung chita so there is current. Okay, kutel current I have magnetic field hung so na so so there will be magnetic field. So there we know that that B is equals to mu naught into N into I. Okay, so here I'm going to replace this N into I with a letter H. H become magnetic intensity. Okay, magnetic intensity due to the current in the solenoid there is magnetic field. So which means here B to mu naught into H. Okay, equation 1. Now H ki put my me bacho so here H means that the magnetic field that is due to the current. Okay, so solenoid if I put some other medium inside, material inside. So Coulomb's law in a medium T bolzula na. Kutila solenoid air hilawa material dan kakoita so some material is placed. Okay, kutila let's say chipahin it has some magnetization. It's a material pahin. So magnetization on 18 that means it will create some kind of magnetic field on its own. Okay, so it will generate some magnetic field. Due to this material magnetic field parts na. So let's say this is a B naught due to na. So B naught is due to the current. So BM due to the material medium na. So mu naught into capital M magnetization. Okay. So this is given in NCRT. So due to the current you have mu naught into H. Due to the magnetic material you have mu naught into M. Net is at ta asungacha. So B net inside will be so B naught plus BM. So which is mu naught into H plus mu naught into capital M. So which is mu naught into H plus M. Okay. Question 3 na abale next to magnetization to intensity ka amani ka relation pa hai na so here relation between so capital M and H so capital M I can write this as so constant psi into H. Okay, psi to become susceptibility, magnetic susceptibility na. So now I'm going to replace this M here. Okay, so therefore B net to PM. So B net will be so mu naught into so H plus psi into H. So which means mu naught into so 1 plus psi into H. Okay, so it's like 1 plus psi pa hai na. So this is actually the line na. So here so here I have B net to PM. So B net so mu naught into 1 plus psi into H. Here 1 plus psi kitipa hai na. So this is actually so mu into R. This is a permeability of the material. Okay, permeability of the medium na. Mu naught so permeability of free space is a mu R so permeability of the medium. Therefore B net final to so mu naught into mu R into H. Numerical ho kitong decho chala hi. So mu R to PM, so mu R is 1 plus psi. 그때 magnetization to magnetic intensity 주선 주나 해장 주 해려 준 희징 and next is so magnetic properties na heji hi psi relation jana okay let's susceptibility question ho na lang pe previous question ho select kan hapul lo so whatever question they have asked you directly from this table 5.2 na select ko na so mu betang psi heza mu r heza mu naught to mu relation na heza like mu pa hi pikase na so what is mu here is basically mu naught into mu r okay a product pa ko na right so that is mu table zo hina ba ha jing de question kan solve it na so an iron rod of susceptibility to psi value kp na jela psi to pm 599 is subject to magnetizing field of 1200 the permeability of the material is batang b to pm okay jela mu also so here mu is asked mu is basically mu naught into mu r na okay khutele mu r to pita so therefore mu r to 1 plus psi na so which means 1 plus 599 to 600 in na lai so therefore what is mu to mu naught to 4 pi into 10 power minus 7 abana mu r to 600 okay so how much is this so for 6 are 24 100 pi into 10 power minus 7 so 2.4 pi into 10 power minus 4 okay so I think this is the answer so 2.4 10 power minus 4 a numerical question na okay magnetic property chain pen pena chuna chi magnetic property so piham dimagnetism paramagnetism to ferromagnetism jana chi heji hi NCERT latest NCERT na 147 140 149 line by line na sim deu phate ana sim jo this is previous question ho direct as like nang ke dong so I'll show you one okay ka sa deu tang suppose check question ni beta so you are given the A B C D point likhi pi chala na so you have to choose the options point number 1 khom so paramagnetic substance a question ke dong so chala na so they have aligned themselves along the direction of the magnetic field so hoila ko na kela ham si they have aligned in the same direction along the magnetic field okay which means the first one is correct yeah ani na pa khola they are attracted strongly but here paramagnetism are weakly attracted okay so therefore B is wrong na line by line na symbol e bon head chu C no susceptibility little more than 0 as a table ka sai pa chu so para chu susceptibility chu chi na je so it is epsilon to be 8.85 into 10 power minus 12 so this is a very small value na 0 para chu 8.85 10 power minus 2 ki ka chu it is very little na so has a little more than 0 so that is also correct it moved from strong to weak it moved from weak to strong okay so this is wrong na so answer is A and C okay hechi question solve thai ding achona hechi phati an sim ngai jo okay you have to read it line by line na it's like permanent it possesses a permanent magnetic dipole moment ki chong hi important point ni chona so okay you have to write it go by line athuma na so dimagnetism paramagnetism ferromagnetism athuma na sim dio okay then that much okay magnetism cha ki chai na ki phale electromagnetic induction involved so I hope you understand so lecture thoma magnetism chapter ali alen cheo he so class 12 fadinga topic poi mo pen loi jana magnetism he right and I will stop here I hope you understand and then I'll see you in the next lecture okay